Hi guys, welcome back. In this video, I want to talk about the double angle identities. So in this video, I'll only write the three double angle identities, and I will try to also show you how we get some of these. And then in the other coming videos, I will be doing some examples based on those three identities. So guys, the first one is the sine of the double angle. So let us start with that, sine of 2 theta, but I want to call it double angle. And once we are done with the double angles, then we are going to talk about the half angles as well. So with double angles, sine of 2 theta is given as 2 sine theta cosine theta. And you can, again, it's all in your formula sheets. But guys, for something like this, I actually wanted to show you how we get some of these. I'm not probably going to show you all of them, like how we derive all of them, but let me show you maybe one or two of them. So guys, to get sine theta equal to this, I mean, it's not too complicated. You already know the sum and difference formula. So we simply have to use the sum formula, which we already know, in order to get this look like that. So let me quickly show you that. Guys, the left-hand side here, the left-hand side, so this is the left-hand side LHS, is sine of 2 theta. So let us try to break down this left-hand side and see if this is we are gonna like simplify it, and then let's see if this equals to the right hand side, which in this case is 2 sine theta cosine theta. And guys, the first thing is like when I look at both these sides, I don't see like there's any room for simplification on this side, but there seems like there could be some room for simplification on the left hand side. That's why I chose to work with the left hand side. It depends on each particular identity or each particular problem where you want to start, okay? Here it makes sense to start from the left-hand side. That's why I'm starting with the left-hand side. So what I can do with the sine of 2 theta is I can break it down as sine of theta plus theta, right? Because theta plus theta is 2 theta. So theta plus theta, right? So when I look at this sine theta plus theta, which is sine 2 theta, which is my left-hand side, then when I look at this piece, theta plus theta, it reminds me like this is the sine of, this looks like sine of A plus B, like sine of the sum, right? You can think of this as A, this as B. Okay. And we already talked about the sum and difference formulas and how to use them in my previous videos. So we already know the formula for the sine of the sum. So let us go ahead, use your formula sheets, or if you remember, let us start writing the formula. So sine of A plus B is sine A, right? Sine A cosine B. In this case, A and B, the angles are the same. It's going to be sine theta cosine theta, then plus, again, cosine theta and sine theta, because the angles A and B both are theta. Okay, so guys, I can write this as sine theta cosine theta. They are multiplied, right? Since they are multiplied, it does not matter whether we write cosine times sine or sine times cosine. So I'm going to rearrange this a little bit. It's going to be sine theta cosine theta, right? I'm allowed to do that because they are multiplied. It's like 2 times 3, or writing it like 3 times 2 is the same thing. Guys, what do we see here? They are exactly the same 2 terms. So if they are exactly the same 2 terms, we can just add them. And if you add them here, all you're going to get is 2 times sine theta and cosine theta. And isn't that what we have in on the right hand side? So we basically verified, or we proved one of the double angle properties for trig functions. Sine 2 theta is 2 sine theta cosine theta. And we were able to do that using the sum property of trig identities that we already know. Okay. Similarly, the second one is the cosine of 2 theta. So we can do the exact same thing for the cosine 2 theta. We can break this down as cosine theta plus theta, and then use the sum of the cosine formula, and then finally we'll end up with the formula, which looks like, in this case, it is slightly a little more like complicated than this one. So the formula looks like this. It looks like this: cosine square theta minus sine square theta. That's how the formula looks like for cosine 2 theta. Okay. And guys, for this, there's few more ways of expressing this, and we are going to like express them. And you should go ahead and try using the same method to see how you get from this equal to that I would like you to do on your own. But I'm going to show you the other 2 ways of representing cosine 2 theta as a formula, as an identity, which you will find on your formula sheets. But I'm also going to show you how we can do it. It's not too difficult to do that. So guys, one thing I can do here is, we already know that the cosine square theta is 1 minus sine square theta. That is from the Pythagorean identity, the very basic ones. Again, we have covered those. So we can replace cosine square theta by that, and then there's the minus sine square theta, right? So if you simplify this, it's going to be 1 minus sine square theta minus sine square theta. So combining like terms, so these are like terms, so it will become 1 minus 2 sine square theta. So cosine 2 theta is equivalent to this. Cosine 2 theta is also equal to this. Now, what is the difference between this one and this one? Guys, you can clearly see the difference. Here, we have both the cosine and the sine. But if we look at this one, it only has the sine function. So sometimes, if we want to only use the sine function, then we use this identity. If we want to use both, then we use the first one. And there's a third one as well. Guys, starting from this one, I can leave the cosine square theta as it is. What I can do in here is I can replace sine square theta by using the basic Pythagorean identity that sine square theta plus cosine square theta is 1. So if I solve for sine square theta, that would come up to 1 minus cosine square theta. Again, I'm just using this basic Pythagorean identity. Now, if I simplify this, I got to distribute this negative. What will happen? I'll get cosine square theta minus 1, and negative becomes positive. Cosine square theta, this and this, these are like terms. We can combine those. So what do I get? I get a 2 cosine square theta minus 1. We have the third one. So for cosine 2 theta, we can express it like this, or this, only in terms of sine, or only in terms of the cosine. There are 3 ways for representing a cosine 2 theta, and now it depends on a problem whether you want to use this one, or this one. For sine, there's only one, so I mean, we just have to use that one. Guys, that is sine and cosine. So I think for the tangent, I would like to do this in the next video. So guys, till then, just try to practice and see how we get these two. And then in the next video, I'm going to show you the tangent one. And after that, we're going to use those to actually verify or prove other trig identities, right? Okay. So I'll see you in the next video.